Good evening, everyone. Today we're going to be talking about sampling. Before we get into sampling, there's a couple of different things I want to talk about. As you'll remember, last week we covered the topic of threats to validity. We talked about the different types of validity, and we talked about internal threats to validity or threats to internal validity. There's a couple that don't quite easily apply to internal validity and really apply exclusively to control groups. And so I want to talk about those separately because they kind of fall somewhere between threats to internal validity and sampling, because they have to deal with when you choose a control group and use a control group, some of the issues that might affect your research outcomes that are the result of how the behavior interaction with that control group works. So the first you see here is this idea of contamination, absorption of elements by the program, by members of the control or comparison group during this study, right? A good example of this is if you were to be doing a new, let's say you were taking a different type of school intervention, right? You're training teachers on a new way to teach their students, and you randomly chose half of the teachers in a particular school to get the new learning strategy, and the other half did not. Right? What would end up happening is the fact that all those teachers are in such close quarters that there's very likely a possibility that the teachers who were getting the new training are talking to at lunch or in between classes and things like that with other teachers who are not, who then kind of learn about what's going on, and while they're not participating in the program, right, they start to then adopt some of these new practices in their classroom. And what happens when that occurs is that you have this contamination effect, right? The control group is no longer untreated, meaning those who are the teachers who are supposed to be in the control group now start to do some of the program elements. And what happens is, right, while you'd want to see improvements in student learning outcomes amongst the treated group, you'd start, if the program works in theory, right, you'll actually start to see improvements as well in this contaminated group now. And so that throws off what you hopefully want, which is a strong counterfactual. And this counterfactual is this idea where what would have been the same, or what would have been if the same participants had not been exposed to the program, right? The intervention. So this idea of what would have happened if I would take, all 30 of my students, and then, if I could have trained you all on this research methods topic using one teaching strategy, and then had all of you unlearn that and then tried a different way of teaching you without that new strategy and see what happens in both situations, that would be kind of a perfect world scenario to know whether that program works, right? The problem is we can't really do that. The way of unlearning is not really necessarily possible. So what we end up having to do is we establish a control group that serves as a counterfactual. So we want 30 students like you who potentially are in maybe Dr. Powell's class learning research methods his way, right, which might be the same, but I'm going to adopt this new technique, and therefore they're going to represent this idea of the counterfactual, right? The what would have happened to you had you not received this new treatment, right? Obviously, this contamination threat, right, if Dr. Powell starts learning what I'm doing and how I'm teaching you differently and starts to adopt that in his own classroom, right, those students no longer represent this idea of the counterfactual, right? Because they are not what would have happened if they weren't exposed to the program intervention, right? Because this part right here is now very important because they did get exposed to some of the program intervention. Obviously, in an example like that where there's 2 teachers only, right, the contamination becomes a big problem because all students in the one classroom have been contaminated. In the teacher's example in the school, you might have 100 different teachers in the control group. Only some of them are going to fully understand the new program itself. Even a subset of those are actually going to adopt it. And so it ends up becoming one of those scenarios where, it's not necessarily going to be full and utter contamination of everybody, but the problem is you don't know to what extent that contamination occurs. The other threat to know is this idea of compensatory rivalry, right? The group who's in the control group seeing themselves as receiving this less desirable form of treatment or the absence of it, and then becoming more competitive as a result, right? An example of this might be if we have a nutrition program that's supposed to help people lose weight, get in better shape, and eat better, right? And we can only help 25 people into the program at a time, and so we have people that are on a wait list. We use this wait list to serve as our control group because it's a good counterfactual of people who signed up for the program, and therefore maybe we don't have the selection bias problem as much, right? But if there's a big, if all the people that are not chosen to participate initially are very upset that they weren't chosen and decide, well, I don't need this program, I'm going to get in shape on my own, and while I'm waiting, I'm going to change my diet and I'm going to exercise and all these other things, right? That is the competitive result, the resulting behavior that becomes the issue, that now has that same effect as the contamination, right? That control group starts to overall try to eat better, get healthier, right? And when we wanted them to represent the kind of status quo of people who want to be in this program but right now aren't doing anything and receiving the benefits, like they are actually now creating sort of this additional challenge where they are starting to improve their own outcomes as well, and again are not representing sort of a strong counterfactual example. So those are two kind of additional threats to consider. And while we talked about your X's and O's framework, either one of these two, again, they're going to be threats. They may not be the biggest threats, and I think in most cases in the practical world, you're not going to have what I would call total contamination or total compensatory rivalry, which is like, if you have 100 people in a control group, all 100 change their behavior, all 100 are contaminated, and then all of them are affected equally at the same level of the treatment group, you're likely to have a very small subset of people receive some type of contamination. Not everybody's going to go to the gym. Some might, right, and start changing their diet, but a lot are still just going to wait for their turn, right? And some of them aren't going to see the same outcomes, because if your program is meant to do a better job, right, than someone trying to figure it out on their own, then you'd hope that those kind of outcomes are going to be only potentially skewed by, for a small number of people in your control group. But they're things to be aware of, and they're particularly useful just to think about when you talk about research design, because you want to try to avoid any potential risk of this, because that's just best practices in terms of minimize as many threats or eliminate as many threats as possible, so they're not issues that could potentially affect your research overall. So getting into sampling, right? These key terms of sampling. There's a number of different things here that we're going to talk about. And there's, as I mentioned before, there's going to be 3 different YouTube videos to go along with this one that you should watch afterwards. Each of them are going to talk about a lot of these different terms, and they're going to give you some idea of how sampling works and draw out examples and things like that in different ways. I think they all are going to kind of convey the same message, but in different ways of communicating it. But you're going to hear a lot of these key terms, right? The first one is population, right? This is kind of considered your largest body of, and I'm going to say people in this case. It's not always people. A lot of times when we think of sampling, right, the most probably stereotypical example of this is, election season. We're trying to predict who's going to win a presidential election. We want to know who people are going to be voting for. And so one of the things that has to happen is, well, we can't ask all 300 million people in America who they're going to vote for. So we have to choose a subset, right, a sample of people that are going to represent, that are the people we're going to actually ask the feedback of. We're going to use that to try to extrapolate to that broader audience, right? That broader audience is the population. Right. In this example, that broad population is all voting eligible citizens of the United States. Right. That might be 300 million people. The reason I say it might not be people is because we might also be, let's say we work for the U.S. Treasury Department, and we've got a giant palette of freshly printed, $20 bills. Right. We just produced 10,000 of them. We believe that there might be some type of an error in the manufacturing process, and so we're concerned, and we need to do inspections of these bills. We don't want to inspect all 10,000 of them, so we've decided we're going to randomly choose a subset of 500 bills to check to see if they show any signs of this imperfection in the printing process. In this case, the population we're talking about is the 10,000 bills that we're going to be choosing a subset of. And so that's why it's not necessarily always going to be people when we talk about population, right? But the idea is that, you know, if we have every single one of these X's being, right, everybody in the state of California, every person in the county of Los Angeles, right, every patient in a hospital, right, every whatever it happens to be, right, this big broad unit is our population. That's not to be confused with the term census. So census is a thing, ironically or not, done by the Census Bureau, right? The census is a thing that happens every 10 years, right? You may hear this term because the 2020 census is coming up, right? And this is where everybody in the Census Bureau goes to every single household in America, right? And asks a whole bunch of survey questions to people to find out, right, how many people live there, how much they make, what their demographics are, right? How do they have healthcare coverage, all those types of things, right? So the census really is, it's more of this idea of kind of a national survey, right? That's done every 10 years by the Census Bureau, right? So census is typically talking about that process to perform a census of the American population, right? So it is like a survey, but it is not choosing a sample. It is actually intended to get the entire population of America to answer that. That's not usually what happens, but that is sort of the intent, and the effort is to ask everybody everywhere that they can get to answer the questions. Right. A sample, this is usually a subset, right, of a population. So once we typically have a population, the reason for sampling, and this part's pretty important, the reason for sampling is because the population itself is too large to practically be able to get a lot of information from, right? Or not necessarily a lot of information from, right? But right, 10,000 bills to inspect might be too many bills for us to look at with only 2 inspectors in one day to make a determination as to whether or not that there was a printing problem, right? We've got a couple hours or something like that. We can't inspect them all. We have to take a subset of them, right? If there's 300 million voters in America, if every couple days during election season we want to find out who's got the lead in the presidential primary or the, you know, in the electorate, we can't ask all 300 million people every single time, every single day, right? It's just, it's logistically and practically it's just not feasible to do that. So one of the things that we have to do oftentimes is to be able to take a sample, right, a subset of that population. So we might, you know, take in this example, right, we're going to choose only those people who are circled in blue because it's a smaller number for us to deal with, right, and get information from them, right? And then we're going to use what we get from the blue group to estimate, right, or extrapolate broadly back out to what we think, right, the population would say. And what you can see here is, well, there's a lot of red X's that we didn't necessarily get information from. Doesn't that leave us open to error in the prediction about what they all think, right? Because we didn't ask everybody, we asked only some of them. That is true. And that fundamentally is the biggest reason why choosing a sampling approach becomes so important, because there's a lot of different ways to choose those blue circled X's. And because of how you choose, you may have different amounts of issues with generalizing back to that broader population. One point that is really important is also that sampling implies that you need to choose a subset of a population, and your sampling methodology has to do with, well, what process are you going to use, right, to figure out which, you know, in this example again, which X's do you draw the blue circles around, right? How do you pick which ones? Right? I just went around the circle and drew a number. There's different ways, right? I could have counted every second X and circled that one. Right, I could have circled, you know, if I went 1, 2, 1, 2, 1, 2, worked my way around this way, I could do it that way, right? And I could have chose every second person, Right? I could have said, well, what's easiest is, if this is geography, let's say this is a county boundary, right? And I happen to have my office here, right? These might be the easiest people to ask because they're the ones closest to where I'm at, right? So any one of those has to do with which that you choose. What's an important point, and this sometimes trips people up in the research design part of this, is that sampling requires the choice of a subset. Sometimes the population is not so big that you need to necessarily choose a subset, right? Sometimes in evaluation design, you may not necessarily have a sampling design for necessarily a treatment group. And I think it's also important is, right, if you have a treatment group and you have a control group, right, you may have a sampling design for one and a different sampling, a different sampling design for the other, or one for one and one for the other, or none for one and one for the other, right? Something like that. So if you think about the fact that maybe I'm running a boys and girls club and we have a new pilot program we're going to run, and we only have 15 kids that are going to sign up for this initial pilot program, right? Are we going to choose a sample of the 15 participants because it's practically difficult to get survey data from 15 people, right? No, right? I mean, if it's children who are in our building, right, we can ask them questions. It's not that much work. And therefore, we may not sample at all because we don't need a subset of 15. The population itself is only 15 persons. It's a small enough number. No sampling is needed. However, if our control group is going to be similar children in that neighborhood that are like those participants, right, socioeconomically and demographically, right, well, there's a lot of people we can choose from because there might be hundreds or thousands of children in that community that have similar characteristics. Right? Well, we're going to have to pick a subset of them, right? So we may have a sampling approach for our control group, right, but none for our treatment group. Right? The control group might also just be, there's only 50 people that participate in our Boys and Girls Club overall. So the 35 that are not participating are going to be the control group, and the 15 that are participating are the treatment group, right? That's our whole population. There's really nobody else, right? So whether you have to sample or not is dependent on the population, and it's going to be very context specific, meaning you have to think about, right, that question or that idea of, well, who is the broader population, right? If I'm talking about American voters and who they're going to pick as the next president, right, I have a big population to deal with. I can't ask all of them, right? I might be talking about voters in my neighborhood, in which case, if I only care about, my neighborhood, quote unquote, maybe 4 or 5 blocks around my house, right, it's actually pretty easy if I wanted to go walk door to door and ask everybody, because there might only be 50 houses or something like that, right? So you have to have a population, right, and you have to define it, but the choice of what that population is also going to define what happens with your sample. Sampling frame. Clear up some space here. So sampling frame, typically this, if you think of, right, maybe your list of people, right? And again, this is not always a list. In modern, probably day and age, this is more likely to be a database system output, something like that, right? Basically, this is the idea of what you choose. You choose your sample from, right? So if I have, I'm doing a survey of MPA students, I might actually go to the registrar's office and they can go into the PeopleSoft Oracle database system and then find every student who is listed as an MPA major at the graduate level, export that as a spreadsheet, right? And now there's a list of 437 students, right? That list of students is now my sampling frame from which I can choose, right? Well, I'm gonna only ask 50 people to give me their feedback, so I have to choose a sample of that 430 some odd folks, right? The sampling frame I'm gonna use to choose from is now that list, right? So it might be, it's rarely ever necessarily a list of people. or say list of dollar bill serial numbers. Not usually on paper. These days, it's usually probably a computer database system that includes everybody's information. It could be a map that shows every single house. So, we have 500 homes in our town, and we might be trying to sample people in our community. Right, our sampling frame might be the list, quote unquote, the map of all the different homes from which we're going to choose households to go ask people their opinion from. Right, so sampling frames are ideal because if you have, right, let's say you have a list of all these students. Right, if you have them all on a spreadsheet, right, you've got name 1, name 2, name 3. Right, now that I have this sampling frame, I can tell a computer randomly choose 50 numbers. Right, it says okay, 2 and 5 and 8, right, were randomly chosen. Now from this frame, I can say this person gets invited to participate, so does this one, so does this one. Those are the names of people who are going to get to be asked to be in my survey. That's part of how I can randomly choose people to participate in my study. Sampling frames don't always exist. Sometimes they're more theoretical, so there is a list hypothetically probably of every registered voter in America, but it's probably not one list. It's probably a whole bunch of lists across different counties all across America. So even though it's technically possible to put that together, it'd be practically impossible to try to have one single list for that. So when we do opinion polling and we try to collect data on voters likely vote, things like that, what we typically end up doing is we just use there's a process called random digit dialing, right? And so the computer automatically pulls different phone numbers over and over again. Those people get asked to participate in the study, and then from there, right, you just keep dialing and dialing and dialing until you get enough people in enough different areas that you feel like you have a big enough sample of Americans. That's becoming a little more challenging these days because of cell phones and technology. So now what happens is there are firms that enlist, they call research panels, and so they'll get 500,000 people across America to sign up to participate in future research requests. And so when they now have this sampling frame of 500,000 voters in America, they can go to that list of people that they have to randomly choose, right, or to choose all women who are mothers who are Hispanic, and narrow that list down to ask those then people to provide their feedback and stuff like that. Sampling design, right? Here we're talking about how you choose the subset, right? So the sample. You have a large population, you have a smaller sample of that population that you had to identify as the people that you're going to have participate in your research study. Right? Sampling design is the description of how you're going to choose that sample of people from the population. Like I said, there's a lot of different ways to do it. They all come with different strengths and weaknesses depending on the choice. Ultimately, for your evaluation proposals or things like that, the key is that you have a description of the process so that you're transparent and somebody else can read and interpret how it was that you went about choosing that sample. Right? Statistic and parameter, these two tend to go hand in hand. And so here's kind of an idea of this, which is if we have a large population of people, let's say this is our population, which is again all the red X's. Let's say this is every student at Cal State Long Beach, and we want to know the average height. Right? In red, we can say that the average height is maybe 5'6". Right? In red, we have the parameter because that is not an estimate, that is the actual factual height, average height of every student in our community. Now, if we go back and we do the sampling approach where we have to choose, right, a number of people, right, we might then say, okay, well, let's everybody that's circled in blue, what is their height, right? You figure out the average height of, right, those folks, and we can say, well, that the average height of everybody in blue is 5 foot, right, 3 inches, right? The blue number, right, is a statistic. And this is where the idea of statistics comes from, is this notion that, right, we are computing a statistic, which is an estimate of what the parameter is, right? And what we're dealing with in statistics is the idea that, well, 5 foot 3 inches, right, does not equal 5 foot 6 inches, right? But, right, how confident or close do we feel, right, that this estimate is pretty good, right? So when we have a parameter, we're talking about the total for the population. The statistic itself is the estimate for the sample that we're using. And then there's another term on the next one, right? Generalize or generalizability, right? When we come up with the statistic, we're generalizing that the actual average height of everybody that's a red X is 5 foot 3. We're generalizing that because we don't actually in real life typically know this number, right? And that's what becomes difficult is, well, you know, until election day, and even then, we don't know who all 300 million people are going to vote for, as we wouldn't know how tall everybody in America is, right? So to come up with the average height of an American or how much or what the average vote for a presidential candidate is going to be, right? We take a sample, we come up with a statistic, the number in blue, and we generalize to this broader population. Right? So think of the kind of blue circle here as our generalization, right? We're making a claim about a larger group from a subset of them that we are getting information from, right? Obviously, if you think about stereotypes, stereotypes tend to be, right, a negative idea. There's positive stereotypes, but generalizations about a larger group based off of observations of a subset, right? We typically say, well, that's not representative of the larger group. Right? That is true, and that's why stereotypes are problematic. And that same logic is the reason why statistics and estimation techniques are so important, right? Because if your statistical number, right, is like a stereotype where it doesn't represent that general population well, it means that you've got a really bad estimate, right? And if I end up coming up, right, and saying that, you know, well, 4 foot 6, right, is the average height of a person because I just happen to choose inadvertently or intentionally the shortest of everybody in this bunch, when in actuality 5 foot 6 is the average height, I'm much worse off than if I had come up with a 5 foot 3 estimate. Right? And so that's why the generalization part becomes an important thing. Right? We care about this idea of generalizability, right? And this is kind of extrapolating, extrapolating, right, about the population based on statistic. This might be one statistic or multiple, depends on how many things you're estimating, right? But extrapolating about this broader group, right? Inferring about what the parameter is, right, from the statistic. So there's different types of sampling, and this is really talking about types of sampling, right, designs, because we're dealing with, I have a large population, I need to choose a subset. How do I choose that from them? In what way, right? Non-probability, this is another way of saying non-random. And typically you'll hear random or non-random as the types of different sampling designs. And in this case, right, we're specifically dealing with the idea of equal probability, right? Randomness, pure randomness in a mathematical sense means, right, everybody out of 1,000 people in the population has an equal chance of being chosen, right? If there's 100 people, everyone's got a 1 in 100 chance of being chosen into the sample, right? If they don't have a 1 in 100 chance, right, that means non-random. So, you know, it's not the idea of like, oh, I bumped into my friend at the mall who I haven't seen in 2 years, that's so random, right? It means, right, this mathematical element is the case, right? So non-probability sampling, right, the most common tends to be this idea of reliance on available subjects, or what we call convenient sampling. Right? When we're dealing with convenient sampling, what we're talking about is, right, I need some people I don't have a lot of time or resources or a sampling frame or anything like that. I'm going to pick a group that's convenient, right? So let's say I'm doing a study of Long Beach State MPA graduates or MPA students or public administration students in general, right? I'm in the front of the class, you're all sitting in front of me. I guess who I'm going to ask to give me their feedback, right? The 25 or 30 all of you, because it's convenient. You're there. I know you're all MPA students. I don't have to go find any more who aren't on campus right now. That's a convenient sample, right? Purposive or judgment sampling is this idea that, right, we are intentionally choosing, convenient sample. I mean, really, this goes kind of hand in hand, but it's more of a convenient sample because it's non-random, but it tends to have, kind of, I'll call them parameters to them, right? Meaning, right, there's a purpose, there's judgment calls about who we choose in there. So it's not random, but I care about MPA students who are women, who are also mothers and are working full time, right? So while I have no random way of choosing those people, right, I might use a convenient sample, but anybody who, I have 2 people in my class who are women and work full time and have children, so I'll ask them to participate, right? And then I will let everybody else not participate, and I will keep trying to seek out people, or I might, find from the, I might ask the department chair or all the other faculty, like, hey, if you know anybody who's a woman, who's a student in one of your classes and also has children and works full time, can you send them my way for this study, right? That's kind of an example of a purposive or judgmental sample, because we set these parameters that people must be, right, female, right, an MPA student, right, works full time, and has kids, right? So we set these parameters, and then we kind of use this convenience approach. And what you'll see is a lot of these can be intermixed. So you might have multiple approaches to sampling. So snowball sampling, this is the idea of asking for referrals. It's very common for typically hard to reach populations. So if you're dealing with homeless persons, for example, you might find a population of homeless folks out, on the streets. You might ask them to tell you, do you know anybody else that's homeless that hangs around here often? Or maybe where I might be able to go to find other people, like where else do they hang out? So that you can go and ask those people to participate. And then when you get there, ask them to make recommendations for where else you might find people, right? So if you think about the snowball, right, and you've got kind of the mountain, you start the small snowball and you roll it down the hill, and it gets a little bigger, picks up more snow, it gets a little bit bigger, right? More snow, right? And then you get the bigger idea, right? So, you have people here, you ask for referrals, they send you, this is the referral process, you get more people, they send you through another referral process, you get more people, right? And so on and so forth. And that's how you build up the size of your sample. We used to do this at the Government Accountability Office too, where we'd be interviewing cybersecurity experts to talk to them about air traffic security and aircraft security. There are not that many cybersecurity aviation experts in the world. I don't really have a good book of all of them readily available with all their names and phone numbers. And so we'd interview a couple people, right? And we'd ask them, well, who else do you think we should talk to at the end of every interview? Right? And they'd refer, maybe 3 new people and 1 other that we had already talked to. And they might refer, 3 or 4 new people, including the same couple that we'd already spoken to, right? And so what happens is you do that, and then you build up hard to find populations easier by getting recommendations from people who, they all worked in that sector. They all basically were able to pretty easily refer people because they know all those people where we didn't. Right? Quota sampling is the idea that, right, if I have a sample of people, again, non-random, this might be convenient sample, but I might say that I want, I want 50% men and 50% women students, right? And I want a mix of people where I also want half of them to work only part-time or be unemployed, right? And I want the other half to be, right, people with full-time jobs. And so, let's say I have 200 total people I'm trying to get, right? My sample size is 200. I need 50 people here and 50, 50 males who work part-time or unemployed, 50 females who work part-time or unemployed, 50 women who work full-time, and 50 male students who work full-time, right? And so this may be, right, I've set these quotas, right, of 50%, or, it might be 20%, 80%. A lot of times, if we only have, say 30% of our MPA program is men and 70% are women, right? We might actually choose to have this be 70% and this 30% because we chose that quota because it represents that population that we have, right? And this is typically common where, like, if you can't randomly sample the student population, then, I know that there's 30% male students. I don't have a sampling frame. I can't randomly sample them all, right? But I want a sample that at least kind of reflects the student population a little better because I know that I've set these quotas for myself, right? And maybe this is, say part-time versus full-time students. Maybe we know that, I don't say 80% of our students are full-time, only 20% are full-time students. Based off of that, we can actually map out, what percent of each of these different groups should be, 200 people should basically be in each of these, right? So, in the top row, we should have 160 people between this box and this box, right? And, out of 160 people, 70% would be 112 people, right? And therefore we'd be looking at 48 students here, and so on and so forth. And so we can figure out how many people, right, should meet our quota requirements to make sure that we have everybody represented however we want to break down kind of those different parameters. Right, probability sampling, again, this is the idea of also random sampling, right? Provide useful descriptions of the total population, right? We're talking about, right, the population again, and by useful descriptions, we're talking about, right, we want generalizability from the group, right? The biggest issue with non-random sampling is that we run the risk, again, of misestimating, misgeneralizing about the population because we didn't have everyone getting an equal shot at being in our sample, right? So if I ask, let's say I ask all of my convenient sample students in my classroom how they feel about the department adding 6 extra units being required to the degree program in the next fall semester, right? And it just so happens because I teach research methods that everybody in my class is in their last year of the program and they're all going to be gone. So when everybody says, well, I don't really care about the tuition, or I don't really care about extra units being added to the curriculum, right? I don't have a class that represents or is generalizable to the larger population because all of them are at the end of the program and therefore don't reflect the diversity of students who are not all at the end of their program. So by the fact that every one of you said, well, I don't really care, right? That's not generalizable to that, it is generalizable, but it's erroneously presuming that the total population has, no strong feeling towards adding extra units to the program. And that's the mistake of me because not everyone had equal chance, including first year students that are just starting who may be much more adverse to that in the first place, right? So random sampling, right? We want individuals from a population must contain essentially the same variations that exist in the population. Right? When we choose a random sample, we get equal probability of, or everybody in the sample has equal probability of being chosen from the bigger population, which means it should look very much like the population as a whole, just a subset of them. Right? When it's not random, you run the risk of misrepresentations. It might be more women or less women or more seniors or less first year students or more full-time students. Any of those type of things can happen when you use a non-random approach. Right? Bias, this is the issue. Not typical or representative of the larger populations they have been chosen from. Right? We introduce bias by having a sample that's either non-random or misrepresentative and doesn't generalize to that larger population. Right? It is a biased group, right? Or our statistic may be biased from the parameter. That's typically the mathematical or the statistical issue that we run into is, how biased is your estimate, right? Well, if it's very biased, it's a very bad statistic, right, it doesn't reflect the parameter, that means your error's, pretty bad, right? Basic probability of sampling is as representative of the population from which it's selective. We will get a representative sample if there is an equal chance of being selected in the sample. If there's 100 people, right, and I draw, say I put 100 numbered balls in a bin, spin them all up, I grab 10 out of there, right? That everybody in the 100 had an equal chance of being selected because they were all in the hopper. Right? If I take 1 through 50, right, and I just say, well, I don't have 100 balls to put in here, I only have 50, so I'll just choose from the number 50, right? Number 51 through 100 didn't have an equal shot of being selected in the sample. They had a 0% chance of being selected, whereas everybody else had a greater probability of being chosen because their balls were in, right, the sample. So they actually had like a 1 in 50 chance from a population of 100, which is basically like a 2 in 100 chance as opposed to a 1 in 100 chance. Whereas the other people who I didn't represent by extra balls, if I didn't have them, only had a 0 out of 100 chance, and therefore, right, there was not this equal chance of being selected. Different types of probability sampling. Again, different types of random sampling. This is another situation where these are all random, but they're all different ones that could potentially also be combined into a thing, right? Simple random sampling. This is kind of the idea of right, the hopper example that we talked about. I might have, 100 students on a list, right? Here's all their names. I might use a computer program that says, randomly choose, 20 numbers out of a population of 1,000. Right? It spits out numbers, and I say, okay, right, number 2, 3, 6, 8, yada yada yada, all these people. Right? Those are the 20 that got chosen by the computer. That's a simple random sample. Right? That's the computer version of saying I've got 1,000 balls in this hopper. I'm going to grab 20 of them. Whichever numbers are the 20 that I choose are the people that get invited to participate. Right? It's random, but it's extremely simple. That's okay. Sometimes that's the easiest and most practical way. Right? If you're thinking about a program where you have a wait list and you have to choose a subset of people to be first admitted to the program, there's a very fair way of actually choosing that because you've got, you have a equal chance of being allowed to participate, and therefore you just pick that subset, and then everybody had an equal shot. Right? Nobody was necessarily at risk of not being selected, and it's a very simple way of doing it. Hence, the simple part of the random sample. Right? Systematic random sampling. Let's say we have 100,000 people, and so it's a little bit harder to get 100,000 lottery balls and try to pull 100,000 numbers out of a hat. What you might do is you might choose a particular number, right, at random and say 237, right, and then I'm going to choose number 4, right, and so this might be this might be a number from 1 to, let's say, 500,000 because that's how many people I have. This might be a choice between 1 and 10. Right, and then what you do is you go to the 237th name in the database system or whatever, right, and then you choose them to participate. 238, 230, 239, 240, 241. What happens is you then will go 1, 2, 3, 4, right? This number is the next person to get to participate, right? And then 1, 2, 3, 4. Right, that's the next person. And so this is how you choose, right? And basically you then use that systematic process to pick as many people randomly from that list as you need until you get to 200 or 500 or however many people you plan on having in your sample. In a practical world, you probably keep inviting as many people as you can until they all actually complete the survey and you get 200 people to do it. As opposed to inviting 200 and only having 20 answer. You might keep going back to the well, but you use the systematic system to choose the first person, to choose the interval between, right? And then now that you have a huge list, you know where to start, you know how many people to choose from, and then you keep repeating that to pick people. The stratified random sample, there can be proportionate and disproportionate, right? So think of strata as delineations of the population, right? You're breaking the population into categories. A good example of this might be you have a high school and you're getting feedback from high school students. And you have freshmen, you have sophomores, you have juniors, and you have seniors, right? All right. So we've now taken our class and we've divided them into these 4 strata, right? Our freshmen, our sophomores, our juniors, and our seniors, right? These are the different strata that we have, right? I'm making that one here. Right. So we've chosen our strata first because we want to break them up into categories. Right. The difference between proportionate and disproportionate, right? Let's say we know that we have, in actuality, right, we've got, say 20% of our students are seniors, 30% are juniors, and then let's say 40% are freshmen. Let's do it this way. 80, 90, right, 10%. So we have, really bad dropout problem at our school. And so while we start with 40% of our students being freshmen, we have about a 10% attrition rate per year. So 30% of our students are sophomore, 20% are juniors, 10% are seniors, right? So this adds up to 100% of our student population, but they're represented by each of these strata being represented by the percent of the student body that's made up by freshmen, sophomore, juniors, or seniors. Right? If we want a proportionate random sample, right, we might basically say, well, we want a sample of 100 students, right? To make it proportionate, right, we have a list of every freshman, and what we're going to do is we're going to randomly choose 40 of them, right, to be invited to participate in our study, right? And because we have 30% are sophomores, we're going to make that proportionate. We're only going to let 30 people participate that are juniors, 20 that are juniors, 30 that are sophomore, and 10 people out of 100 will be seniors, right? So these numbers are, right, these are proportionate to the actual population. These are still randomly chosen, and the reason that we use the strata is because, right, I didn't choose a list of all high school students and randomly choose 100, because, I mean, if I do that, odds are I'm going to get about 40% freshmen, but I might get 38% or I might get 45% or something like that, because if everyone's got an equal chance, it's likely going to represent that general population characteristics, which are these numbers here, right? But if I want to ensure that I'm going to get exactly 40%, I can first divide it up by these, right, grade level strata, then have my list of only freshmen, and potentially use either systematic or simple random sampling to then choose 40 people that are going to be from that list. And now I know they're all freshmen. I can do the same with the list of sophomores to get my 30, same with the list of juniors to get my 20, and then the same with the list of my seniors to get my 10. Right? Disproportionate, right? If I know that 40% of my student body are freshmen, 30% are sophomores, 20% are juniors, and 10% are seniors, I may not really want 10 out of 100 people to only be seniors, because if I'm doing a survey on high school dropout rates, I might want to get more opinion from the seniors, right, and the juniors that are represented by these proportions, because, well, they're the ones that are at higher risk, and I want to figure out like why they're still around, because freshmen, there's always a lot more of them, right? It's that loss that matters. So what I may do is I may say, well, I'm going to make this disproportionate. I want, 25%, or let's say I want 20% freshmen, I want 20% sophomores, and I want 30% juniors, and I want 30% seniors, right? So I'm still going to have a sample size of 100 people, but I'm only going to choose 20 freshmen, 20 sophomores, right, 30 juniors, and 30 seniors. So I go back to my list of seniors, and while I have less seniors total in the school, I'm going to randomly choose, again, either by simple or systematic random sampling, 30 names from that list instead of 10, right? Go back to my juniors, choose 30 from that list, 20 and 20 from those lists to get my total numbers, right? And that's now a disproportionate stratified random sample because I've chosen to use different proportions here that don't reflect the actual proportions of the school intentionally, but I'm still using a random sampling approach. And then cluster sampling, this tends to be one that gets done more geographically. And so this is where you do, if you're doing like anything that has to do with neighborhoods necessarily, or you have like parks or things that are community based. Typically what happens is if you have like a big map, right, and you've got all your kind of different neighborhoods, right, you got your city blocks. Let's say all these are houses, city block houses. Something like this. Cluster sampling is this idea that, well, geographically, let's say this is a really, really bad map of Los Angeles, right? Might be a really good map of Wyoming, for example, because it's the same shape, right? Well, if I'm trying to go door to door to collect information from people in Los Angeles County, right? What I don't want to do is go choose this house, this house, this house, this house, and this house via a simple random sample, because now I'm driving all over the place to try to get information about what the community residents think, because geographically that's not convenient. So simple random sampling might say that I'm going to randomly choose right from the squares, and say in blue I randomly chose via let's say we numbered each of these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? I've got 16, we'll call them clusters, right? And I can choose, again, using simple random or systematic random sampling, right, a subset of these numbers. So let's say I randomly choose number 1, number 7, number 10, and number 16. Right now what I've done is I've chosen my clusters, and what I'm going to do is, because those are randomly sampled, I'm going to then just go ask everybody in each of these areas to give me their feedback, to try to get a better opinion of the ideas of the community, right? And so, yes, there's a number of different clusters or boxes that aren't being represented. I'm getting more people to respond, and everyone still had an equal chance of being chosen, because I chose from this kind of overview map different clusters within the community, and then got as many people or all households within that to basically respond. So this is something like the Census Bureau does, but this is also really good where, let's say this is a big city, and we're building, let's say there's a park that's going in, right, in this blue shaded area, right, that's going to most likely affect these different neighborhoods or city blocks, right? You don't really want to deploy a survey to everybody in the city of Long Beach, because there's going to be houses, way out here that are never going to probably reap the benefits of this new park. You care about these different neighborhoods here that are actually going to be adjacent to it, right? But you can't necessarily get every home to participate, so you can randomly choose to get people who are within, maybe this is 1 square mile of the block, the park's perimeter, right? And from there, you then use cluster sampling to choose, neighborhoods or blocks or, clusters of homes to then participate in your sample, right? And so you can use something like that to then choose a subset of houses geographically. So this is something that when you do GIS, or what we call geospatial analysis, right? So if you know the Esri products, right, we use, typically this is done with maps, because you start with maps to be able to identify these different clusters, these tracts, right? And then you can choose for them, right? So Census Bureau chooses from census tracts or block groups or things like that, because in between the censuses that occur every 10 years, they still collect data, right? But they don't do the whole all out every household approach. They use cluster sampling to identify, census tracts or blocks in the off years, to then go get information to then try to update and forecast numbers about the larger population as a whole. So that's the introduction to sampling. One of the things that you're going to be asked to do next week is you will have a discussion board post. So don't forget, after you finish this video, you'll then want to go to the Beachboard folder where there's going to be 3 other YouTube videos for you to take a look at that all talk about sampling. I encourage you to watch all of them. Sometimes the information is going to overlap, but they're only, I'd say like no more than 5 to 10 minutes each. So it's a pretty quick watch. But basically, you're going to have the discussion post. So for next week, you should be answering the following 2 questions. Can you use probability sampling? So any type of random sampling, whether simple, systematic, stratified, cluster, any of those, to choose a sample of participants for your evaluation proposal, right? This might be your control group, this might be your treatment group, or it might be both. If so, just briefly explain which sampling design you can use and whether or not a sampling frame exists, right? So is there a data system or something like that that can be utilized as a sampling frame to help you choose people from it, right? If not, and no is a perfectly acceptable answer, and just say no, there's no random sampling ability because there's no sampling frame because it's too large of a population and I can't choose from it, and that's actually quite common as well. If not, then describe what type of non-random or non-probability sampling designs, whether it's a single version of one or a combination of multiple. So convenience sampling, judgmental sampling, snowball, or quota, which can you use? If there's multiple, or if you're going to use a combination of each, a combination of multiple, describe the interaction between the 2, right? So I might use a convenience sample to find the homeless population that comes into my shelter, and then I'm going to use snowball sampling to talk to them to then identify additional persons out in the community to be part of our control group and or treatment group, right? And then if you're going to use one of these non-random approach, do you feel like there's a sampling bias issue, or is there going to be problems with your sample not necessarily being generalizable to the population, right? And obviously any type of non-random sample, there's going to be some bias, right? But just talk briefly about where you see that potential threat being reflected based off of the decision that you're making. And so that's everything we're going to cover for sampling for this week. As usual, if you have any questions, feel free to shoot me an email, post them on Beachboard, anything like that. I'm happy to get back to those to you as soon as I can.